Dear students, it is clear from our earlier discussions that in the Solow model, capital accumulation by itself cannot explain sustained economic growth observed in the real world. And one of the objectives of growth models is to explain sustained growth in national income and also per capita income. In the Solow model, as we have discussed in the previous classes, high rates of savings lead to high growth rates, but only temporarily. And economy eventually reaches a steady state in which capital and output, capital per head and output per head will be constant. Stated differently, saving has only a level effect. It has no growth effect. That is, an increase in the saving rates increases capital per head and output per head, but only for a short period. And this is known as transitional dynamics, as we have discussed in the previous classes. Now, to explain sustained growth that we observe in real world, that is growth in national income and also per capita income, we have to expand the Solow model to incorporate two other sources of growth. One is population growth. Population growth. The other one is technical progress. So to explain sustained economic growth, observed in different parts of the world, we expand Solow model incorporating population growth and technological progress. And in this session, we will consider population growth. Now, as it is known to you, population growth increases the size of labor force and it causes economic growth. Population growth increases the size of labor force over time, fueling economic growth. And assuming that the ratio of workers to population is a constant, assuming that the ratio of workers to population remain constant, then we can say that the number of workers in the labor force grow at the same rate as the rate of growth of population. And in the Solow model, population grow at a rate is equal to N, is equal to delta is equal to N. So, assuming that the ratio of workers to population is constant, the rate of growth of the rate of growth of labor force is equal to the rate of growth of population. Now the question is, how does population growth affect the steady state? How does population growth affect the steady state? Now, to discuss this issue, we must discuss how population growth along with the population growth along with the investment and depreciation. In order to understand how population growth affects steady state, we must discuss population growth along with the investment and depreciation and its influence on capital accumulation or capital per worker. Now, as we have noted earlier, investment increases the capital stock, and on the other hand, depreciation reduces it. Investment increases the capital stock, depreciation reduces it, and net investment is the difference between gross investment and depreciation. Now, the third factor acting to change or determining the capital per worker is growth in the number of workers. The third factor which affects the capital per head is growth in the number of workers. Growth in the number of workers, as it is clear from this ratio, causes capital labor ratio to fall. So, when the number of workers is growing and if capital stock is constant, there will be capital dilution. Capital dilution will take place. If K is constant, L increases, K by L, capital per head decreases. Or what we say, capital dilution will take place. As an example, if delta L by L is equal to N is equal to 1%, then machines K must grow at 1% to keep K by L constant. If machines capital is not growing, then K by L will decline, capital dilution will take place. So, if N is growing at 1% and assuming that the ratio of worker to population is constant, a 1% increase in the machines is required to keep capital labor ratio constant. Now, we can show the effect of population growth on capital labor ratio by subtracting capital dilution N into K by L, Nk, from capital accumulation formula. Now we write it as delta K, rate of change of, that is the rate of growth of capital labor ratio, delta K. That is the increase in capital labor ratio is equal to S into Fk minus, in the previous class, one factor causing capital dilution is lambda K. With this we add the population growth, so that this can be written as S of K minus lambda plus En K. Now the fundamental equation becomes, that is the equation which determines the growth of capital labor ratio is now S of K minus N plus lambda K. That is, population growth affect capital accumulation in the same way as depreciation affect capital accumulation. So depreciation reduces K by L because a part of the capital accumulated will be used for replacing wear and tear. Population growth also lowers K by L because capital should be provided to the increased labor force over time. So with the addition of the labor force growth or population growth, the steady state equation changes only slightly. S of k minus lambda k has become S of k minus lambda plus n k. This is savings per head. This is now depreciation per head. This is savings per head. Fk is y, S into y by L. This is S of k is equal to S into y by L, savings per head, and this part is nothing but depreciation per head. Lambda plus n into k by L, depreciation per head. Now we can show this this equation using a graph similar to the Solow diagram, which we have already introduced. Now consider this. Now instead of lambda k, it is now n plus lambda k, and this is S of k, and this is f k, k star, and this is y star, k star, y star. Now in the figure, steady state capital labor ratio is given as k star, determined by the intersection between S of k and n plus lambda k, where I star is equal to S of k star. I star is equal to S of k star, and the corresponding steady state output per head is y star. And as is the case in our previous discussion, if actual k is less than k star, economy move towards k star. If actual k is greater than k star, again economy move towards k star. And the explanation is the same explanation which we have provided in the previous sessions. So in the steady state with the population growth, capital per head and output per head are constant. And consider this carefully. This is k by L and this is y by L. K by L and y by L. And the population is growing, that is delta L by L is equal to n. Population is growing at a rate equal to n. That point should be remembered. Now, population is growing at a rate equal to n, but k by L is a constant. So k by L will remain a constant when population is growing at a rate equal to n, if and only if k is also growing at a rate n. Similarly, y by L is a constant if y is also growing at a rate equal to n. So in the steady state, k by L and y by L are constant. That is, output per head or per capita income is a constant, but national income is growing. Similarly, capital per head is a constant, but capital accumulation is increasing. So, the addition of population to Solow model helps us to explain sustained increase in total output. Sustained increase in total output, but it cannot explain why output per person is growing, or addition of population growth cannot explain sustained increase in per capita income which we observe in the real world. Sustained increase in per capita income which we observe in the real world. So, in the absence of population growth in the Solow model, when the steady state is reached, as population is not growing, GNP is also not growing. It is remaining constant. Capital accumulation is not taking place. Only replacement is happening. But with the population growth, capital per head is constant, means capital is growing at a rate equal to n. Output per head constant means output is growing at a rate equal to n. That means we can explain sustained increase in GNP, but we cannot explain sustained increase in what is known as per capita income, which we observe in the real world. And to explain sustained increase in per capita income, we have to introduce technological progress. That we will see in a later session. So, even with the population growth, K by L eventually reaches K star, output per head eventually reaches I by L. Moreover, when the economy is in the steady state, delta K is 0. Delta K is 0. Although economy experiences what is known as capital widening. Widening means capital per head is not increasing, but more persons are employed using the same amount of capital as population is growing at a rate equal to n. So, no capital deepening is taking place. Capital deepening means capital per head is increasing. What is happening here is only capital widening. So, in this version of the Solow model, there is no long run increase in per capita output. Total outputs grow at the same rate as population. Y and K grow at the same rate as population. Per capita income remain constant. So, long run growth in the Solow model is n, constant exogenous rate of growth of population, and is independent of savings, independent of the rate of savings. Long run growth rate is equal to n, independent of the rate of savings in the economy. Now, in the next session, we will consider what happens if there is an increase in population growth. This is the Solow model with the population growth. Now, we have to consider what happens to the steady state if there is an increase in population growth. Just as we have considered in the previous class, what happens if there is an increase in the saving rate.